Friday Math Happy Hour. We're going to be doing factoring for 1324. Okay, so let's see here. Hey guys, I mean, factoring is a very important topic that most students, when they get to Cal 1, Cal 2, they have to know I mean, factoring, how to factor. And this is where the two majors separate. For example, if you're taking 0324 or 0124, I mean, your major is probably going to be business math, 1324 and 1325. If you're in 0114 or 0314, that means you're going to go to 1314, which means most of the time is going to be the majors, I mean, related to math, computer science, and engineering. So I just want to, share with you guys how important it is to know how to factor. Okay. Okay. Now the purpose of factoring. The purpose of factoring quadratic expression is to eventually lead to a method of solving a quadratic equation. The x-intercepts, solutions, and zeros and roots, it all means the same thing. Okay, let me show you with a graph what we're talking about. Okay, now you see this where the graph crosses the x-intercepts are the x-intercepts, the solutions, the zeros, or the roots. Right? Like I said earlier, it means the same thing. Okay, now say for example, if you had a function, this graph here belongs to the function negative x squared minus 2x plus 8. So to find the x-intercepts, you have to know how to factor. And this is how you factor, right? But I'm going to show you step by step how to factor something like this. You see, these are my solutions, which are the x-intercepts. Okay, now, there are plenty of examples from real life about quadratic functions. For example, anything that has to do with an arc is a quadratic function, like this bridge on top. Also, this animated bridge also you see has an arc. This is a polynomial with many arcs here. Okay, the McDonald's sign also has arcs. These are quadratic functions also, and these are the ones related to some of the material covered here at the college. This is profit. When somebody kicks a ball, right, you're going to find the maximum height and all that stuff. You use it by finding the vertex and also the x-intercepts. But these here, guys, where the graph crosses the x-intercepts, that are the four words that means the same thing, which are x-intercepts, roots, solutions, and roots. Okay, now this is I call it a factor sheet. This is what I tell my students to bring to class. Okay, some instructors, they don't like for students to use handouts, but for me, guys, they cannot use it on the exams, but it's good, like a good idea to have it with you. This way you know exactly what factors are. For example, the factor sheet here, here on the right, this is like a calculator. It gives you all the factors from 1 to 100. And also the factoring steps, I'm going to show you each step here, guys. There's like 1, 2, 3, 4, 5, 6, 7, 8 different ways of factoring, which I'm going to cover everything in this PowerPoint. Okay, so let's start here. And again, these is a copied from that handout, the steps to factor. Okay, to start off, well, number one, you have to know what the GCF means. What's the greatest common factor? Which means what is the highest factor to factor out? That's the first thing that I'm going to explain. But before we do that, we have to know the vocabulary. A quadratic expression is an expression involving a square term. For example, everything that has a square, like x squared, y squared, whatever, but a 2 as an exponent, that's called a quadratic function or quadratic expression. Now, what are factors? Factors are numbers multiplied together to get another number. Example, what are the factors of 12? Which means how can we get 12? 1 times 12, 2 times 6, and 3 times 4. So the factors of 12 are 1, 2, 3, 4, 6, and 12. Okay, let's do another example. Example 2, what are the factors of 20? It means how can we get 20? 1 times 20, 2 times 10, and 4 times 5. So the factors of 20 are 1, 2, 4, 5, 10, and 20. Now comes this is step number 1 on the factor sheet. What is the greatest common factor? The GCF. The GCF of a set of numbers is the largest factor that all the numbers share, or the highest number they have in common. Okay, it means, in other words, of saying the same thing. Example, what is the GCF of 12 and 20? You see, we would have the factors of 12 here, an example 1 and example 2. Example 1 is for 12 and example 2 is for 20. So what are the factors they have in common? They have in common the 1s, the 2s, and the 4s. The 4 is a GCF because it's the greatest common factor, the highest number they have in common. That's 4. So the GCF of 12 and 20, which is the greatest common factor, will be 4. So 4 is the answer. Okay, now, here's how you can use the factor sheet. Hey guys, I didn't use a factor sheet because at times, students that are right out of high school, they're the ones that actually know what factors are. But there's some students, like for example, like myself, when I came back to school, I was 43. So those are students that I try to target. Why? Because those are the students that need the most help. And eventually, by targeting those students, everybody gets picked up at the same time. That's why students feel like comfort when I tell them that they can use this, but not in the exam, right? But they can use it like to know what factors are. Now I'm going to show them how to find the GCF between the 12 and the 20 by using this handout here. Okay. And if you like a copy of this handout, at the end, I'm going to put my email and my phone number there on the chat. This way, if you guys want a copy, come to my room or I'll send you one online, okay? By email. But anyway, here's how we use it, okay? The GCF of 12 and 20. So how does this factor sheet work? Okay, so I'm going to get the 12. The 12 is here, right? So I'm going to bring it down here. There's my 12 in green, so I'm going to bring it out. And the 20, it's right here on the second row, the last column. I'm going to bring it down. So by using this handout, it's kind of visual, right? So what's the highest number they have in common? Right away, we know it's 4. That's how we use the factor sheet. And again, there's many instructors that let them use a calculator like a scientific calculator, but they don't want students to use this handout. And to me, it's almost the same thing because scientific calculators, they also have like a mode that has find the GCF and they can find it there. That's why I do let them use this handout also in the exams. I believe I said not earlier, but I don't let you use the factor sheet, but this they can shoot. This they can use, but not the steps, because this is just like a calculator. Okay, now, so the answer was 4, right? Now, how does the factoring steps work? So let's start with step number 1. Greatest factor to factor out. Okay, so this is what I'm going to target now, the first step. So when you see something like what's the GCF of 20 and 30, right? Find the factors of 20 and 30. So how can we get 20? 1 times 20, 2 times 10, right? And 4 times 5. These are the factors of 20, but you can also use the factor sheet, which will be faster. But now I'm going to show you the way it should be done without the factor sheet. How can we get 30? 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So what's the biggest number? What's the numbers in common? But the biggest number is obvious that it's going to be 10. So the GCF between 20 and 30 is going to be 10. Okay. Okay, now what is the GCF of x squared and x cubed? I guess when you have variables, for example, if both terms have an x, right? X squared is the same thing as x times x, and x cubed is the same thing as x times x times x. If you notice, how many x's do they have in common? They have in common 1. They have in common 2. So the answer will be x squared because x times x is x squared. But here's an observation. Okay, if both terms have the same variable, which means have the same letter, that's what variables are. The variable with the smallest degree or the letter with the lowest exponent is the GCF. So between x squared and x cubed, they both have x's. So it's a 1 with the least exponent, which will be x squared. Now, this is step number 1. Factor out the GCF. Okay, so if they're saying factor out the GCF, right, I already have the 30 and the 20. I did them here on top. So between 30 and 20, what do they have in common, right? Wouldn't it be a 10? And here, I tell my students to use the factor sheet. They just go to 20 and 30 and pick the highest number they have in common, which is 10. But the work that I did here on top, guys, this is the way students should do it. But the factor sheet is for the students that actually don't know the factors of certain numbers. And then what's the factor of both terms, right? With the variables, they both have an x squared, right? So this is my GCF. So I'm going to factor it out. So to factor it out, if 10x squared is factored out, what's left? So for example, you can do this by multiplication or division. I like to use multiplication. So here, guys, you can ask yourself, 10x squared times what number will give me 30x squared? The answer is 3, because 10x squared times 3 will give you 30x squared. Or if you want, you can divide. What's 30x squared divided by 10x squared? The answer is 3, right? You can use either or, what's best for you. Now, the sign, we're going to bring it down, okay? And then we're going to do the same thing with a 20, right? So it'll be a plus. Now you can ask yourself, 10 times what will give me 20? The answer is 2. We have x squared, we need x cubed. So how many more x's do we need? We're going to be one more, which is x. And again, you can always check your work. 10x squared times 3 will give you 30x squared, and 10x squared times 2x will give you 20x cubed. So this way I know I'm in the right track. Okay. Okay, now factor out the GCF continues. So for example, here, guys, this is like 2 terms. You see, we have 1 term and 2 terms. So here, we're going to do it the way the book does it. Okay. The GCF is 2x. I don't know, I'm going to do it my way, but then I'm going to show you an example the way the book does it. That way you can see the difference. And this way, if you follow the book, you can do it that way. But I always have like a modified version because, like I said, I always try to reach the students that are non-traditional students. Okay, so they have in common the 2x minus 5, right? So you factor it out. If you factor it out, what's left? It will be x plus 2. So this is the factor form of x, parentheses 2x minus 5, close parentheses, plus 2, 2x minus 5, close parentheses. So this is how you factor it. Okay, now this example is crucial for factoring polynomial with 4 terms. Okay, now this is the way the book does it, okay? The book does it this way. They say, right, if you have 4 terms, you can the first 2 terms is called group 1. And the second and the last 2 terms is called group 2. So you're going to factor those separately. Okay? So let's do the group 1 first. Group 1, the factors of 2 and 8, the factors of 2 will be 1 and 2. The factors of 8 is 1, 2, 4, and 8. The ones that are in green is what they have in common, right? So the highest number in common will be the 2. That's why the GCF of 2 and 8 is going to be 2. Now let's do the variables. We have x squared and we have x, right? So from the x squared and the x, the GCF will be the variable with the lowest exponent, which would just be x. So the GCF of x and x squared is x. Okay? So the GCF of 2x squared plus 8x is going to be 2x. So I'm going to factor it out. So then, right, so you're going to put parentheses, and then you can ask yourself, 2x times what will give me 2x squared? That's why the x is there. And 2x times what will give me 8? The answer is 4. That's how you can check your work. Now you're going to do group 2 over here you bring in the sign, and you do group 2 here on the right. Right, we repeat the process. And group 2, we have the 3 and the 12. So between 3 and 12, right, the factors are 1 and 3 for the 3. And for 12 is 1, 2, 3, 4, 6, and 12. So the highest number they have in common is going to be the 3. So 3 is my GCF. And if you notice, for the variables, the 3x has an x, but not the 12. So they don't have no variables in common. That's why the factors the GCF of 3x plus 12 will be 3. So if you factor out the 3, what's left? X plus 4. Now, now we have a situation like we do here on top. So we have 2 terms, right? So what do both terms have in common? They have in common the binomial x plus 4. So that's what I'm going to factor out. If you factor that out, the 2x plus 3 is what's left. So this is how you factor with 4 terms. Okay, now I always have like a modified version to show students how to factor or to do things. I mean, in general, because some students need more help than others. So I always modify my methods of teaching. Right, first I teach the concept, and then I teach like an alternative way to try to reach every student in my class. So this is the way I modified this. I mean, with 4 terms. Right. So here's how you follow the factoring steps. Okay, the first thing you're gonna do, you're gonna right. This is the step number 1, right, which we already covered. Now step 2, it says determine the number of terms. So since we were doing I mean with the 4 terms, so that's what I'm going to do first. You see, that's why it's here on the bottom, 4 terms. So say the polynomial had 4 terms, then we do it by grouping. Okay. Now this is the way I show my students. Okay, now, right, I'm gonna just get the two first terms. I'm gonna pretend that the 4x minus 10 is not there. Okay. So find the GCF of the first 2 terms. Between 2x squared and minus 5x, the answer will just be x, because with the 2 and the 5, they only have 1 in common, but the 1 doesn't count, because if we factor out the 1, we're going to get the same thing. So in this case, it'll just be x. Okay, now I'm going to factor out the x. So then what's left? Okay, if I factor out the x, right, it will be 2x minus 5. And before I proceed, I can always check my work. X times 2x will give us 2x squared, and x times negative 5 will give me negative 5x. So I know it works. Okay, now what's here on the what was left after I factor out the x, you're going to put on the right side. If it can be factored this way, it will always work. I'll just put down 2x minus 5. The sign, we bring it down. Now something's got to go here, a number or a variable. In this case, you ask yourself, what number times 2x will give me 4x? The answer is 2. And again, you can always check your work. 2 times 2x will give you 4x, and 2 times negative 5 will give you negative 10. So I know I'm in the right track. Now, if you notice, the GCF, right, between the left term and the right term is going to be 2x minus 5, because they have the 2x minus 5 in common. So I'm going to factor it out. So if I do that, what's left? The x plus 2 is left. That's how you factor with 4 terms. Now I put this, guys, so you know that I modified a little bit from the textbook. Here it says the binomial that is left, which is this one here, right? This was left after I factor out the x. What's left, you just put it on the right side. The binomial that is left after factoring the GCF on the first 2 terms will always be the same binomial on the right side if it can be factored by grouping, what I just mentioned earlier. It will always work. Okay, let's do another example. How about this one here? Okay, so let's do it the way I did it with the last slide. Factor by grouping, right? So I'm going to get the first 2 terms. What do they have in common? 3x squared minus x minus 6x. If you don't want to use the factors list of factors, you can always use a factor sheet. Between 3 and 6, what's my GCF? The GCF is 3. Between the x's, right, they both have an x, both terms. Remember that I said that you always pick the least exponent, right? So this is a 2x, an exponent. This is a 1, so we use the least power. So between 3x squared minus 6x, I'm going to factor out the 3x. So what's left? What will be left will be x minus 2, because 3x times x will give me 3x squared, and 3x times negative 2 will give me negative 6. Now, what I factored out, what was left, I just put it on the right side. Okay? The sign on the third term comes down, which is minus. Now, I'm going to ask myself, what number times x will give me 7x? The answer is 7. And again, you can always check your work. Negative 7x times x will give me negative 7x. Negative 7x times negative 2 will give me a positive 14. Now, we have 2 terms left, right? So what does the left side with the right side have in common? The GCF is what they have in common will be x minus 2. If you factor it out, what's left will be the 3x minus 7. So that's how you factor in this one. Let me go back. That's how you factor with 4 terms. Okay, now let's do this. Now let's go to the next one here, okay? So my next step, determine the number of terms, right? So what happens if you have 2 terms, right? I'm gonna do this one here, the 2a number 1 with perfect squares. These are perfect squares. Why? Because x times x will give me x squared, and y times y will give me y squared. That's why those are called perfect squares. If you have x squared minus y squared, the answer will be x minus y and x plus y. If you do the FOIL, if you multiply x minus y times x plus y, you're going to get x squared minus y squared. Okay, another word for these two is called conjugates, but this is not the topic for today. Okay, but that's what they call. Now, if you notice, it only works if you have a minus. If you have a plus, it doesn't work. The answer is prime, which means it cannot be factored. Okay, so let's do examples of perfect squares. Again, this is determine the number of terms, right? So if it's 2 terms, it's going to be perfect squares, right? So let's do examples of this one here. Okay, now, all these in blue on the left are called perfect squares. This is the reason why. Because perfect squares are what 2 numbers multiplied by themselves will give me, for example, x to the 4th. So that's why x to the 4th is a perfect square, because x squared times x squared will give me x to the 4th. X squared is also a perfect square because x times x will give me x squared. 1 is also a perfect square because 1 times 1 will give me 1. 4 is also a perfect square because 2 times 2 will give me 4, right? And so forth. Try to know at least from 1 to 100, right? Which is 1 through 10, really. Okay? And the same thing in the same format. 6 is a perfect square because 4 times 4 will give me 16 and so forth. Okay, now, so how does this work? Remember, if you have x squared minus 1, by following the rule here for perfect squares, it's going to be x minus 1 and x plus 1. X squared minus 4 is going to be x minus 2 and x plus 2. X squared minus 9 will be x minus 3 and x plus 3. What would you think x squared minus 49 will be? Right? Is that a perfect square? Yes, it is. And so is 49. Because 7 times 7 will give me 49. So both of these are perfect squares. So it's going to be x minus 7 and x plus 7. In a similar fashion, x squared minus 81, right? 81 is a perfect square because it's going to be 9 times 9. So it's going to give us x plus 9, x minus 9. If you notice, I switched the sign. What does that mean? It doesn't matter what you put first. What matters is you have the same x times x and 9 times 9, but the signs don't matter. Okay, what you put first. What's x squared minus 100? It's going to be x minus 10 and x plus 10. How about 25x squared minus 36y squared? If you notice, the x squared is a perfect square and the y squared is a perfect square. 25 is a perfect square because 5 times 5 will give me 25, and also 36 is a perfect square because 6 times 6 will give me 36. So it will give me 5x minus 6y and 5x plus 6y. How about x squared plus 36, right? That one, if you notice, is going to be prime because this has to be a minus for the difference of 2 perfect squares. For it to be x minus y and x plus y, this is a plus, so it will not work. That means this one is prime. So just be careful when there's a positive sign there. Okay, it's going to be prime. Now, how about x to the 4th minus 16? This will give you x squared minus 4 and x squared plus 4. If you notice, x squared minus 4 is also, there's 2 perfect squares. X squared and 4 are perfect squares. So this one can still be simplified, but the one on the right, the x squared plus 4, cannot because the plus is prime. Okay? So let's continue factoring more with the x squared minus 4. It's going to give us x minus 2x plus 2, and we just break down the x squared plus 4. Okay, this is going to a little bit to the extreme. You will see something like this. I know this is a workshop for 1324, but you might see something like this when you get to 1325 if you're going for math for business or for accounting. But most of these you see them on the pre-cal route if you're going for math or engineering or computer science. Okay. Now we're going to do 2a number 2, which are the perfect cubes. Okay, these are the formulas for the difference of two perfect cubes and the sum of two perfect cubes. Okay, so this is what you follow. So I'm going to show you an example of each one. Okay, now, here we go. Okay, to make it easier, guys, I just tell my students, number 1 is going to be the difference, and number 2 will be the sum. So you notice, what are perfect cubes? Again, x to the 6 is a perfect cube because this, for perfect cubes, it's saying what 3 variables or what 3 numbers multiplied by themselves will give me x to the 6. In this case, it's going to be x squared because x squared times x squared times x squared will give me x to the 6. In similar fashion, x cubed is a perfect cube because x times x times x will give me x cubed. Also, 1 is a perfect cube because 1 times 1 times 1 will give me 1. Will give me 1. Same thing with 8, with 27, 64, and 125. At least know all the way to 125. The 125 is a perfect cube because 125 is the same thing as 5 times 5 times 5. Okay, now, so if you notice this example, it's going to be like rule number 2 here, right? It's going to be the difference of two perfect cubes. So I tell my students, right, first of all, is it 1 or is it 2? The difference or the sum. Once they know which one it is, so they're going to get to follow the formula. This is the formula that they got to follow, okay? But before we start doing the formula, right, the x cubed plus 125, we have to convert it into this format here, x cubed plus y cubed. So this is going to be x cubed plus 5 cubed will be the same thing as x cubed plus 125 because 5 times 5 times 5 will give me 125. So here, guys, I'm going to let my x equal to x and my y equal to 5. So follow the formula. Everywhere you see an x, you're going to put an x, and everywhere you see a y, you're going to put a 5. Okay, so x goes there. The y is 5. The x squared will be x squared goes there. X times y will be x times 5 will give you 5x. And also y squared will give you 5 squared, right? Now you simplify because 5 squared is 25. So this is how you factor something with perfect cubes. Okay, now let's do one more. Right, again, they're the perfect cubes again, so you can follow. This is a little bit more challenging, right? This you probably never see again unless you're taking the NCBN. This might be there. Okay, so check this out. We know that x cubed and y cubed are perfect cubes. But the 27, right, we notice that the 27 can be rewritten as 3 cubed. And the 64 can be rewritten as 4 cubed. So I know these two terms are perfect cubes. Okay? So the first thing we're going to ask yourself, which one is it? Is it 1 or 2? The difference or the sum? This will be the difference. So I'm going to put the difference formula, and that way we're going to be able to follow it. Okay? So now, so the 27 will be the same thing as 3, right? 27x cubed is the same thing as 3x cubed. Because 3x cubed is the same thing as 3x times 3x times 3x, which will give you the 27x cubed. And also the 4y cubed is the same thing as 4y times 4y times 4y, which will give you the 64y cubed. But this, guys, this ensures with a parentheses that this follows the formula here. If you don't have a parentheses for the whole thing, only the y will be cubed, not the 4. That's why you have to put them in parentheses. So again, I'm going to let x be the same thing as 3x, represent 3x, and I'm going to let y represent 4y. Now follow the formula, right? My x is 3x, my y is 4y, my x squared, right? So we're going to put 3x there. Again, 3x, my x is 3x, my y is represented by 4y, and my y is represented by 4y. Now I get to simplify it. This will give us 3x minus 4y, close parentheses. 3x squared is the same thing as 3x times 3x will give us 9x squared. And 3x times 4y will give us 12xy. And 4y squared is the same thing as 4y times 4y will give us 16y squared. So this is my solution, out of factor. Now comes 2b, right, which will be this one here, 2b with 3 terms. I call this a easy factoring because once you know how to do it, you can say, how can you? It's not that hard. It's kind of easy. And this is a little bit more challenging by grouping. Okay, now there's different ways that instructors do terms with 3 terms. Okay, I'm going to show you first how some instructors do it and also how the book might do it. And then I'm going to show you a modified version for factoring in this in the form of x squared plus bx plus c. Okay, this is for most instructors, or the book tells the student, find 2 factors that the product is 24 and the sum is negative 10. For some students, they are able to follow that, what they're asking for. But others that haven't been to school in a while, they'll say, can you, what do they mean by that? So they're confused. So anyway, this is what it means. Okay. So I'm going to get the factors of 24. How can I get 24? Negative 1 times negative 24, right? That will give us 24. 1 times 24 will give us positive 24. Negative 2 times negative 12 will give us positive 24. 2 times 12 will give me positive 24. Negative 3 times negative 8 will give me a positive 24. And 3 times 8 will give me a positive 24. Negative 4 times negative 6 will give me a positive 24. And also 4 times 6 will give me a positive 24. That's all the possible combinations. Okay, now, with that handout, the factor sheet, you'll be able to do it right, or else you can do it with a calculator, but most of the time, the instructor wants you to know it by heart. Okay? So now, that's what that means. 2 factors that the product will give me 24, so I found the first part. Now, the second part, the sum is negative 10. So now we add them. Negative 1 plus negative 24 will give us negative 25. 1 times 24 will give us positive 25. Negative 2 times negative 12, 2 plus negative 12 will give me a negative 14. 2 plus 12 will give me a positive 14. Negative 3 plus negative 8 will give me a negative 11. 3 plus 8 will give me a positive 11. And negative 4 plus negative 6 will give me a negative 10. And 4 plus 6 will give me a positive 10. If you notice, right, we're looking for negative 10, right? So this is my combinations will be the negative 4 and the 6 is my match. That's what we're looking for. If for any reason, the number which this is called a BX term, if this number was in here, then it cannot be factored. You have to use another way to find the solutions. But in this case, right, this is my match, which means negative 4 plus negative 6 gives me negative 10. That what it means by the sum is negative 10. So now this is how you factor this one. X minus 6 and x minus 4 will give me, the product will give me 24, and the sum will give me negative 10. And this is all the work. Okay? Now I'm going to do one more when you subtract them, okay? Look at this one here. Again, I'm going to follow the method that the book explains it, and also the method that most instructors also explain it this way. This means 2 factors that the product is negative 30 and the sum is negative 7. So again, same format as before. How can I get negative 30? And here's all the possible combinations. Come a little bit fast. That's how we can get negative 30. And now we're going to add them. This will give me 29. This will give me negative 29. The only way the students can mess this up is if students don't know how to add and subtract integers. That's the only way. And now, guys, I've been teaching for a while. Now nothing, shocks me. I've seen students actually taking pre-cal or 1324, and they don't know how to do, how to add and subtract integers. Okay, I don't know the reason why. I'm not there to judge, but I'm there to help them understand. Right, so negative 2 plus 15 will give me the positive 13. This will give me negative 13. This will give me positive 7. This will give me negative 7. This will give me a positive 1. And this will give me negative 1. So if the match, right, we have to get negative 7x, right? So the match is negative 7. So then this here, guys, is my combo. 3 and negative 10 is my combo, what I'm going to use. That means that 3 is positive and the 10 is negative. That's how you factor. Okay, now, I'm going to show you a different version of how to factor. Okay. Now, this is easier for most students. Okay. And if you already know how to factor, don't change because of me, right? If you already know, a method and you get it right. But say that you're completely lost on factoring, this is very helpful because students have told me that. Okay, now this method, I try to do it in two parts. Okay. This here, guys, is called the BX term. This is called, the C is called the constant term. So I tell my students to always focus on the constant term. Okay. If the constant term C is positive, the signs here are going to be the same. If the constant term C, right, if the C is negative, the signs on the binomial are going to be different. Okay. Here, most of the times when I was teaching this class here, it was called the O305. I will give a quiz on the second day of class because that's where you started how to factor. So the quiz was only about telling me what the signs are going to be, positive or negative. That was it. Because once the students know what the signs are, if they're the same or different, they're halfway there. And then the part two are with the factors of the constant term. So let me show you how this works. Example number 1, x squared minus 10x plus 24. Are the signs the same or different? Okay, so here's what I tell my students. Before you answer, look at the rules here. My constant term, right? The constant term, the 24 is positive. That means that the signs are going to be the same. Number 2, right? The constant term on number 2 is negative 30, so the signs are going to be different because it's negative. Number 3, the sign of the constant term is negative, so they're going to be different. Number 4, the sign of the constant term is going to be positive, so the signs are going to be the same. Okay? And again, why is that? Okay, right now I'll show you why. So if it's the same, it's going to be the sum of the factors must equal to the BX term. Okay, and the difference of the factors must be equal to the BX term, and so forth. This is to also to teach a concept. But at times, something like if I tell a student the sum of the factors must equal to the BX term, it might be a little bit confusing for them because they don't know what the word sum is, or they don't know what the BX term is, right? This is my BX term. So the main important here, guys, is the sign of the constant term determines the sign, same or different. That's all I want you to know on this slide here. Okay, now on the next slide, I'm going to actually do the work. If you notice, number 1 and number 2 are the ones that I did earlier on the last 2 slides. Okay, I did it the way the book explains it. Okay, now let's do number 1 here. Okay, now on number 1, we know that the signs are the same, right? So this tells you what they're going to be. There was going to be minus, because negative times a negative will give you that positive. Okay, now, so once we know the signs, right, we put them there. Now, also, guys, we're going to get the factors of 24. And like I tell my students, if you guys know all the factors, right, like in order, there's more power to you. But if you don't and you struggle with the factors, you can use a calculator, like a scientific calculator, or if you want, you can use a factor sheet. I already showed you how to use it. Okay, so anyway, 24 can be done by 1 times 24, 2 times 12, 3 times z, and 4 times 6. So then, also, guys, this sign tells you what you do here. We're going to add the factors. This sign is very important. Well, everything's important, but this sign is I believe, is a little bit more important because it tells you 2 things. It tells you that the signs are going to be the same on the binomials, and also tells you what you do here. You're going to add them. So the sum of the 2 factors must equal to the BX term, which is negative 10, right? So this will give us 25, 14, 11, and 10. So this is my match, 6 and 4. Okay, so I know it's going to be negative 6 and negative 4. But anyway, since we don't know what the signs are, we can go from here to the answer, right? This is my match. It's going to be 6 and 4. That's my answer. Okay. Let me do example number 2. We bring the sign down, right? We know they're going to be different. Hey, guys, if you bring the sign down, the biggest factor always goes first, which I'm going to explain why right now. It's going to be minus and plus, right? So we get the factors of 30. How can we get 30? 1 times 30, 2 times 15, right? 3 times 10, 5 times 6. If you notice, right, on the slide that I did it the way the book does it, it did -1 times -30 and all that stuff. Right here, you don't have to do that. Just get the factors, right? And then we're going to subtract them because the sign here is what we do here on the factors. So 30 minus 1 will give you 29, 13, 7, and 1. Okay, now. So I know that my match is 3 and 10. 3 and 10 is my match, right? So I know that -3 plus 10 will give me my -7. But if you bring the sign down, if you notice, if you bring the sign down, the biggest number always goes first. And that's what I modified also here. Again, the sign of the bx term, this sign of the bx term determines the largest factor. So if you bring the sign down from the beginning, you don't have to worry about that. The biggest factor always goes first if you bring the sign down. You said the sign of the bx term is brought down, then the largest factor always goes first. Okay, that's if you bring the sign down. Now the next two examples I'm going to do it kind of quick, right? This is the way I show my students after I explain all the concept. Okay, the signs are going to be different because it's minus. So this sign comes down. So it's going to be x plus something and x minus something, right? We get the factors of 20. Then this tells you, right, that we're going to subtract them. 19, 8, and 1. What's my match? My match is 1, right? Because it's 1x. So the biggest number goes first because I did bring the sign down. So 5 goes first and the 4 goes second. Once my students know the rules, they're able to follow like in detail, and it seems real easy for them to factor. Similar here, right? So this is a plus, the signs are going to be the same, and they're both going to be positive. Right? Now factors of 15, there they are. And this means also that we get to add them, 16 and 8. Where's my match? The match is 3 and 5. So I'm going to put the bigger number first and the second and the smallest number second. Here's where students tell me, Mr. Isasi, can it be 3 and the 5? Yes, it can, because when the signs are the same, it doesn't matter the order. Only when the signs are different, when you subtract, it's where the sign of the bx term determines the biggest factor. But I tell my students, you know what, students, it always matters. Always put the bigger number first. This way, they don't get it mixed up. Okay? And I even tell them, if you tell an instructor that I said that the bigger number goes first, they're going to say that maybe that guy doesn't know what he's doing, right? But I don't care what they say. I just care about my students. And again, if you bring the sign down, right, especially when you're subtracting, the bigger number goes first. So if you want, just put the bigger number first all the time. That way you eliminate mistakes. Now comes the last thing, the last part of our PowerPoint here. This is factoring by grouping. This is a little bit more challenging. Okay, but I already explained about the signs, and I already explained when you have 4 terms is by grouping. Now, at times students tell me, Mr. Isasi, what does the 3 terms, 4 terms, 2 terms, and factor mean? This is a sequence that you have to follow, right? Because you're going to start with 3 terms. Then the next step has to have 4 terms, and then 2 terms, and then comes my answer. So this is for them not to know they're on the right track, which I will explain as I do an example. Okay, so now we're going to do to be right 3 terms. This means that with the 8, that means that there's a coefficient there that's not a 1. What's the difference between 1 and 2 here? This one means there's nothing there. Yeah, but there is a 1 there, but we don't write 1x squared, right? But we know it's there. When the coefficient is not a 1, it's a number, right? Any integer, then we do it by grouping. Now, there's another way to do this one, okay? This method here is called by trial and error. But that might be a little bit challenging for students. That's why I stick to grouping. Okay? Here's a rule for grouping. Here it says when you have a number here, you're going to multiply the first term and the constant term. You see, that's what that means, A times C. So I'm going to multiply the 3 times the 10, which will give us 30. Now I'm going to get the factors of 30. Okay, and here they are. Now this means that we're going to add them, right? So what's 30 plus 1 will give us 31. 15 plus 2 will give us 17. 10 plus 3 will give us 13. 5 plus 6 will give us 11. My match is 11x, right? And it's positive. So then before I I converted to four terms. I'm going to convert the 11, which is a bx term, convert it to 6x plus 5x. And again, I always like to put the bigger number first to keep it uniform, as I've been explaining, on every slide. So we go from 3 terms. Now the next thing is going to be 4 terms, right? So the 2 at the corners, they stay how they are. We're gonna convert the middle term, the 11x, into 2 terms, and we got them from here from the factors. So it's going to be positive 6x and positive plus 5x. You see, we went from 3 terms to 4 terms without changing the actual equation, right? Because we got the 3x squared, we got the positive 10, and the 6x plus 5x gives me my 11x. Now we do it by grouping, how we did them at the beginning. So what do the 3x squared and the 6x have in common? 3x. If you factor it out, what's left is going to be x plus 2. And before you go on, you check your work. 3x times x will give me 3x squared, and 3x times 2 will give me a positive 6x. Now remember what I said, guys? When I was doing it by grouping, what's the binomial that was left, you put it on the right. It's going to work every time if it was here, which it was, right? It was 11. Now the second sign we just bring down. Now you can ask yourself, what number times x will give me 5x? And the answer is 5. Now you went from 3 terms to 4 terms. Right now we have 2 terms, 1 term on the left and 1 term on the right. Now what do they have in common? Or what's the GCF? Is x plus 2. What's left? The 3x plus 5. So I went from 3 terms, 4 terms, 2 terms, and here is factored. Okay. Now let's do one more example here. We have 2x squared minus 3x minus 9. So again, the first step is the GCF. They don't have nothing in common. So I get to multiply the 2 and the 9, which will give me 18. Right now we get the factors of 18. How can we get 18? 1 times 18, 2 times 9, and 3 times 6. Right? And this tells you that we're going to subtract them. So 18 minus 1 is 17. 9 minus 2 is 7. And 6 minus 3 is 3. Right? So this is my combination, right? Because the bx term is 3. Now, we have to match it. I tell my students, before we convert it to the 4 terms, we match it here to make sure that we get it right, right? So this is negative 3x. The negative 6x plus the 3x will give me the negative 3x. So the negative 6x plus 3x will replace the negative 3x on the middle term. Right? There it is. Replace it. Again, it went from 3 terms to 4 terms. The next thing is going to be 2 terms, right? So we're going to factor the GCF on the first 2 terms. What do they have in common? I believe it's going to be a 2x. What's left? X minus 3. And again, before you move on, you check your work. 2x times x is 2x squared. 2x times negative 3 will give me negative 6x. This is called the distributive property. So I know I'm in the right track, right? So the binomial that was left on the left, you also put it on the right. The second sign comes down. Now you can ask yourself, what number times x will give me 3x? The answer is 3. I went from 3 terms, 4 terms, 2 terms. Now comes my answer. What they have in common? The x minus 3. What's left? My 2x plus 3. Factored. I believe we're almost done here. Now, let me show you how crucial it is for you guys to know how to factor. Okay, these are math courses. They're all over the place, the factoring. This is Math 1324, section 1.7, quadratic equations, page 58. Use factoring to solve each equation. See? This number 7 will be the easy factoring. Also number 8, the easy factoring. Number 13, we're going to do it by grouping. And number 17, our 2 terms are both perfect squares. This is 1325, which is a business calculus, which is students going for majoring in accounting or business, right? Again, this you're going to do it for limits and also for finding the critical numbers, right? You see, we're doing limits now, right? You have to factor that one, the numerator, and also the denominator, and then try to simplify. Also 1314, section 1.5, find the zeros of the function algebraically. The zeros are the x-intercepts. These are all examples. You also see this in the pre-cal too. But these are like solving trigonometric equations. This is similar to the 4x squared minus 1. This is x cubed minus x. Also calculus 1, problems limits, and critical numbers. You see, we have to know how to factor. These are also for derivatives, right? We have to know how to factor. Also in calculus 2, finding the area between two curves and partial fractions. If you notice, all the numbers, the more math that you take, the numbers are not that big anymore, right? Because when you show you how to factor in the NCBN, there's where all the big numbers are. So they assume that if you know how to factor with big numbers, then the other courses are not that complicated because everything is very small, if you notice. And these examples come exactly from the book. Also linear algebra, which is Math 2320, differential equations. They also have that, computing eigenvalues. You see, same thing. That's like the lambda, but it's the same thing as x. You see, guys, I just show you the importance of factoring, and I hope this video, this PowerPoint, makes a lot of sense, because eventually you have to know how to factor, especially if you're majoring in mathematics. I want to. Does anybody have any questions? If not, let me stop sharing my screen, and I'm done with this PowerPoint on factoring. I want to thank you.
Thank you, Mr. Sassi, for your presentation. We do want to remind you all about the previously recorded sessions, which are available on a YouTube playlist. The session will also be available on that playlist later today. Also linked was a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey. And before you all leave, I want to share the TVE sessions that we will have next. At 1 p.m. today, we will have a presentation by Distance Learning with Luz Cadena. We will be back with Happy Math Hour next week at 11 a.m., where Math 1314 and Math 1324 will cover Exam 1 reviews. Our 1 p.m. session next week will be by the EPCC Mental Health Committee presenting on self-care. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use the chat box or your mic. We hope to see everyone again for Happy Math Hour.